Here is problem 3. In triangle ABC, angle BAC is a right angle and angle ACB measures 34 degrees. Let D be a point on segment BC for which AC is equal to CD, and let the angle bisector of angle CBA intersect line AD at E. What is the measure of angle BED? Pause the video and try to solve this on your own. Using the solution for angle chasing from our last video, let's first start by reading through the problem again and marking all the information we know. In triangle ABC, angle BAC is a right triangle. This is a right triangle. And angle ACB measures 34 degrees. Point D is a point on segment BC for which AC is equal to CD. Oh, so here we have an isosceles triangle, and we know that these angles are the same. And let angle bisector of CBA intersect AD at E. Oh, so we know that this is the angle bisector for CBA. Therefore, both sides of this angle must be the same. What is the measure of angle BED? So what is the measure of this angle right here? We'll call it angle X. Using the solution that we concluded from the last problem, when trying to chase angles and track them like this, when there's lots of different triangles and side lengths and they're just all overlapping each other, it can get overwhelming. So the first thing is to work backwards. Let's first identify what triangle angle X is in. Well, we can definitely see that angle X is in this highlighted triangle right here, in triangle EDB. Do we know the two other angles of EDB yet? Well, not yet. So let's first find out. We'll call this angle A, and we'll call this angle B. Let's first start by trying to find angle A. How can we find angle A? Well, we know that angle A is sitting on angle B right here. And we already know the angle measures of angle C and angle A, which is respectively 34 and 90 degrees. So angle B is equal to 180 minus 34 plus 90. That is 180 minus 124, which gives us 56 degrees. And because we know angle B is then bisected, so 1/2 of 56 is equal to 28. It means that angle A here is equal to 28 degrees. So we'll replace angle A with 28 degrees. Now let's take a look at the smaller angle B. So angle lowercase b here. Well, we see that this is sitting on a straight side with another angle. And we know this angle as one of the angles of the triangle ACD. We know that angle C is 34 degrees. And we know that these two angles are the same because it is an isosceles triangle. So 34 plus 2, let's call it y, is equal to 180 degrees. Therefore, 2y is equal to 146 degrees. Therefore, y is equal to 73 degrees. So if this is equal to 73 degrees, then all we have to do is subtract that from 180 degrees. 180 minus 73 is equal to 107. This means that angle B is equal to 107 degrees. So with all of this complicated, identifying triangles and then finding out their value using interior angle sum, or another one that we've really been using lately is, the straight angles, which is when you see two angles on the same straight line, which is automatically 180 degrees, we can find out angle B, which is 107 degrees. Now all we have to do is find x, right? So we can subtract 107 and 28 from 180 degrees, which gives us 180 minus 135, which then gives us 45 degrees. So in the end, we find angle X to be 45 degrees. And this is our final answer. And these are very common problems that you'll see on the AMC8 and other math competitions at the middle school level, also like math counts. So when looking at these problems, remember, always work backwards. And the two main concepts we've been coming across lately is the interior angle sum of triangles and straight angles.